Okay, real short and easy lesson today about modeling situations with differential equations. So for each of these three examples we're going to write a differential equation, which is an equation containing a derivative to represent the situation. So the first one says the rate of change of y with respect to x is proportional to x. So we would write the rate of change of y as dy dx because it says with respect to x. The rate of change of y with respect to x is proportional to. So is means equal. So equal. Proportional means it's some constant times x. So for this statement, we're going to translate it as dy dx equals k times x. Okay, the next one says the rate of change of the number of bacteria B with respect to T is inversely proportional to the square root of the number of bacteria. So we're going to start out the same way. The rate of change of the number of bacteria, but this time it's with respect to T. So dB dt is, so we're using the is again. So an inverse relationship is like the relationship 1 over x. Inverse means it's, the variables in the denominator. So if it's inversely proportional, that's still going to equal some constant k, but now it's times 1 over the square root of the number of bacteria. So inversely proportional tells us that it goes to the bottom. Okay, let's try one more. There are a total of P persons at a school. The rate of change of the number of people addicted to Calculus Crush, an awesome video game, is proportional to the number addicted, A, times the number not yet addicted. Okay, so we don't need this first statement yet. There's a total of P persons at a school. That'll come in just a second. The rate of change of the number of people addicted. Well, did they give us a variable to use for the number of people addicted? Yes, they did, further down in the problem. They talked about how A is the number of people addicted. So this is a real world situation. They don't tell us what the rate of change is with respect to. The last two problems said with respect to X, with respect to T. So since this is a real world problem, a rate of change is happening with respect to time. As time is passing, there's a change in the number of people addicted to the game. So we're going to write dA dt. The rate of change of the number of people addicted is proportional to, so is again means equal. And proportional means we're going to stick that number k in there, or that variable k. It's proportional to the number addicted, which is A, times the number not yet addicted. So if this is the number of people addicted, we need an expression for the number of people in the population that are not yet addicted. Well, in the population, either you're addicted to the calculus game or you're not addicted to the calculus game. There's no other situation. So if there are P people in the population, if A of them are addicted, P minus A are not addicted yet. Okay, so let's read the problem and make sure our differential equation makes sense. So the rate of change of the number of people addicted to Calculus Crush, okay, that's the left-hand side of the equation, is proportional to, so we put that constant k when we're talking about proportional, the number addicted times the number not yet addicted.